Now this video I'm going to do now is really very short indeed. Basically all this video is explaining the S.U.V.A.T equations and giving them to you. Not really explaining necessarily how we got them, but I'm just going to show you a few examples of them being used, because I'm assuming generally you know how they're formed. If you're watching this video you might not. Probably should do it, but anyway. V squared equals u squared plus 2as is 1. V equals u plus at is another one. S equals half of u v plus a times t, and s equals ut plus a half of at squared. Now, a few things to know about S.U.V.A.T equations. They are given to you on the exam, but it saves you a lot of time knowing them than flicking through the book, which is a complete and utter waste of time. Trust me, I know. You flick through 7 pages, you flip back, you miss a question, you start answering another question, the exam's there, you come to the last second of the exam, you open it and you've still got that question to do, and then you just lie down on the floor and perish. Trust me, it's not good luck. Not that I've done that at all. Anyway, so these are the 4 equations that you've got to look at. Yeah. So you've got your 2 distance ones, S and S, 2 velocity ones, V and P. So I'm going to explain to you. Oh yeah, there's another fact. These all assume that they are at constant acceleration. So you can't use one that goes suddenly at 8 meters per second, and 2 meters per second, and 3 meters per second, and 2. Because that's random. You can't judge a distance, because like if you're only going in your car and you drive at 70 miles an hour, then the acceleration is going to be 0. I mean, it's a constant acceleration, but still no acceleration, but it's constant. So you can use one of these equations for it. Yeah. So, if you are, if you accelerate in your car and then brake, then accelerate and then brake, when you accelerate you're going to cover a bit more distance than when you brake, and when you slow down, like run a slower acceleration, is basically what I'm saying is that. So that's why they need to be at constant acceleration. Hopefully that's explained it to you somewhere in there, I hope. So I'll keep these on the board, and obviously you can just change these and sort these out into different equations. Hopefully you've understood that. Yeah. So I'll give you an equation. This is how you label out your S.U.V.A.T equations. It's going to be quite simple, this one. So an object. Well, I'll just read the question now and then I'll answer it, because there's no point in writing it down if it's only going to be in a few seconds. So an object, and imagine a car travelling at initially 20 meters per second, 200 meters per second, bit excessive. So u equals 20 meters per second. And the acceleration of this car is 2.2 meters per second. And the time, and and the distance it covers is, let's just think of a reasonable distance here, 30 meters. It's probably not right, 30 meters. Right, what is the final velocity of this object or car? So, what you need to do, first thing you need to do is write down everything you're given. Even if you don't know what equation you're going to use, get a mark for showing that you've interpreted the question. And also, the big words like car and long for, or whatever words you use try and trick you. You can put them to one side if they're a bit hard, like if you didn't take English. Got a D in English and you're alright. So anyway, back to the question. So you got, you know what V is, you know what A is, you know what S is. You look for the easiest equation to use. Now it necessarily doesn't have to be one that has all of, like, you could have 4 pieces of information, but if you only need U, A and T, say for example you've got S, how far it's gone, the initial velocity, the acceleration and the time, you don't need to find one that has all them 4 in it, because they will all give you the same answer if you put it in and have the a sufficient amount of information to help you. So if you had U, A and T and S, you could use V to find the final velocity, even though you're not using S, because it's just something else you're not given. And sometimes they may give you an equation where they say the car accelerated did this in part 1, accelerated in this part 2, and accelerated different in part 3. Work out total distance. So you split it up into 3 sections. So the first one, it started accelerating at a low rate, you work out the distance using one of the calculations, and do it for the second part, do it for the third part, but then you've got to add them up. I mean, it's pretty simple stuff, but some people think, I don't know, we'll do it all together, we'll add all the accelerations up, and then people don't get the A star. Weirdly enough. So anyway, back to this one. So we've been asked to find the final velocity, well I've asked myself to, and we look for one that's got U, so we've got, all of them have U. We've got one from that has A, and only these 3 have A, so we get rid of that one. We need one that has S, and we're going to get rid of that one. So, well, you don't have to get rid of it, but it's just easier to find one that it's more likely to fit all your criteria of what you've got. Now, we don't have time in this equation, and the only time is this one, so we can cross out. So we're left with this one, and V squared equals U squared plus 2AS. So we put it into the equation. V squared equals 20 squared, which is 400, plus 2 times 2.2, which is 4.4, times 30. And I've not got my calculator on me. It probably isn't very good. Don't know, it's just disappeared. It's gone walkie, it's gone bye bye. You know, it's gone holiday somewhere. Don't get the time now. Anyway, so you could see what you'd do for that. So you'd work out that, and then that'd get you B squared. So V equals the square root of 400 plus 4.4 times 30. That's how you do that question. Okay, I hope you've got that. If you haven't and you want me to show you one of the 3-step problems I talked about before, please comment on this video and I will definitely go through one of them with you. But I'm just hoping you are able to go through that. Don't feel at all offended if you can't. I won't push you, but you know, just have here if you need me, and enjoy your evening.